And 4 are the tricky ones here. Okay. And I just want to do this example with forces given, just so that you know how to use that. So we're going to say that the large box equals, let's say 50 newtons. And I'm just kind of making up these values. Small box, let's say, equals 25 newtons. Okay. And again, we'll just say the same over here. So large box equals 50 newtons. And, oops, small box is 25 newtons. Okay, so how are we going to deal with this? So the trick here is whenever you have stacked objects, because stacked objects is definitely something you're going to see on your first assessment. It's definitely something you're going to see on your first assessment, and I think it's as like tricky as these can get. Okay. The thing to keep in mind with the stacked objects is whatever object is on top, nothing is weird. Meaning, like, if you're the top object, you have no push or pull forces. You are just the top object. Okay? When you get over here to any object within the stack, has push forces. So any object within the stack, when you have stacked objects, is going to have push forces acting on it. Okay, so we'll just kind of chat about what that looks like. So for small box, this is going to look very similar to like this ball up here, which this ball up here just, we have gravity force pushing down because it's on planet Earth, and then we have, because it is on a surface, we have normal force pushing up. And remember, we always draw normal force perpendicular with the whatever surface the object is on. Gravity force always points to the bottom of the page. Okay. So for top object, nothing is weird. The only thing that's new here is that we have actual forces to label. Okay, so I'm gonna go ahead and draw these arrows about the same length. Again, like, you're just kind of estimating here. Like, draw them, kind of look back at them. Do they look about the same length? We're good to go. Okay. So remember all, and just kind of can type this off to the side. Oops, I guess we have some space down here. Down, if forces that are down or to the left are always going to be negative. Forces that are up or to the right equal positive. Okay, and this is just kind of a weird physics thing. Okay, it's just something that you have to memorize. So let's just keep this in mind as we are labeling our forces. So small box weighs 25 newtons. So that means my gravity force equals negative 25 newtons. Okay, and remember, I'm just kind of pulling these numbers out of nowhere. I know y'all didn't have these to begin with. Okay. The normal force here, oops, is equal to positive 25 newtons. Okay. So these forces are equal magnitude but opposite direction. Okay. Okay, so now for the large box. The large box is going to have a push force acting on it because it's within a stack. Okay, it has an object stacked on top of it. So that means it's going to have that force from that small object pushing down on it. Okay? So that means I'm going to have two arrows pointing down. So when I draw my gravity force arrow, I'm just going to kind of draw it over to the side. Whoops. Did not realize that was box still. And do we see how long I drew this arrow over here? So that means I want to draw my large box gravity force bigger. I'm just going to do it like, maybe like that. I'm just going to label this FG. And we know that it weighs 50 newtons, so 50N. We also have the push force from the small box. Okay, and that arrow needs to be smaller than this one because it's a smaller force. FP is equal to, and again, it's downward, so it has to be negative 25 newtons. And you see how I can kind of like, after I type it, I can kind of move these around so that they are a little bit more clear, like what's what, okay? You want to make sure, like when you're looking back at this, that it's very clear what is labeled what, okay? You don't want me questioning what you have labeled, okay? Okay, so now we need our normal force, right? Because the large box is resting on an object, so it has normal force pointing up. So the normal force here is going to be equal to the push force plus the FG. So Fn, so we just add those two together. So 25 plus 50, we get positive 75 newtons. Since we're up, we're pointing up, we have the positive value. Okay? One of the things that I want us to really notice here, let me just, I feel like this works a little bit better if I have some more space to type this out. Okay, so I'm just erasing these black lines over here using drawing, and then I'm making it like super thick and then kind of just drawing over it. And I'm also gonna do a little bit over here too. Okay. So FP on large box is equal to, make sure it's sized right, is equal to Fn on the small box. Okay, do we see that the value over here, this Fn, is equal to this Fp? That's always going to be the case. And we'll see that on the next page when we have 3 stacked objects as well. And for here, for large box, Fn is equal to Fp plus Fg. Okay, and again, I know this is, whoops. I know this is all just kind of a lot of little details. From here on out, it just starts to get repetitive. Okay? So let's go ahead and go to this. And so the cat and the remote are actually exactly like the little box, big box, because it's 2 objects stacked. So I want to go over number 8, because number 8 is 3 objects stacked. So we have this person's hat, the person, and then the couch. Okay, so I just want to kind of go through this one example, and then I'll give you all the rest of the time to work on this, okay? So let's do the hat first, because we know that whatever is at the top of the stack, that's the normal one. You also always want to start at the top of the stack because the normal for the top object is going to tell you the push force for the next down object. Okay, and we'll kind of go through what we mean with that. Okay, so the hat weighs 1 Newton. So I'm going to draw some tiny arrows here. And so here's the deal. So we have like 1 Newton, 550, and 700. I'm not expecting your arrows to proportionally be perfect here. Okay? What I am expecting is that the 1 Newton arrow is shorter than the 550, and that the 550 is shorter than the 700, and kind of so on and so forth. Okay? Each problem can have its own scale or kind of organization to how long the arrows are. So here for the hat, we have Fg is equal to -1 newtons, and Fn is equal to +1 Newton. Okay? For the person weighs 550, and the person is on planet Earth. So we know that that is gravity force. So I'm just going to make this like a mid-length arrow. And then I also have the hat sitting on top of that person's head. So I'm going to have that super short arrow again. Okay? And again, you're just trying your best with these little tiny arrows, okay? I know that this is kind of, it ends up being a little bit tricky. Okay? So this is Fp is equal to -1n. And again, I'm just kind of arranging that so that it's obvious what's what. Fg is equal to -550 n. And again, just kind of organizing this so that it kind of fits in that space. Okay? So then we have Fn for the person. This is going to be the sum of these two arrows together, okay? So this is going to be a little longer than the Fg. I don't know, maybe like that. Again, this is all just kind of, you're just estimating, okay? So then for this would be Fn is equal to 551 newtons. Okay, then over here with the couch. With the couch is on planet Earth. Couch weighs 700 newtons. So we have an arrow, and again, I'm making this arrow longer than the 551. And I'm looking, and I have this like these black lines here. So I'm just gonna go to drawing my white again. Okay, and I'm just kind of making some space for myself here. So Fg is equal to -700 newtons. I then need to put my Fp arrow. Again, my Fp for couch is going to be equal to my Fn for the object directly above it, which is the person. Okay, so it's going to be a little bit shorter than the Fg arrow, a little longer than the Fg arrow over here. Okay, again, this is all just kind of approximate. -551 newtons. And our Fn here is going to be very big. So this is our largest arrow of all of the arrows. So Fn is equal to 1251 newtons. So again, I just added up the 551 and the 700. Anything that's pointed up is positive, anything pointed down is negative, but we know that these are, the magnitude of these are all equal.